The final topic covered in nomenclature is acid nomenclature. So acids are compounds whose atoms are bonded with covalent bonds. However, when acids dissolve in water, they produce H plus ions, much like ionic compounds. So you have a covalently bonded acid there, and then once it dissolves in water, it produces H plus ions and an anion. So basically an acid is a substance that produces H plus ions. We only use the acid name if the compound is dissolved in water. For example, H2S gas is called hydrogen sulfide gas. It's the rotten egg smelling poisonous substance. However, if H2S gas dissolves in water, then we call it hydrosulfuric acid because it is now dissolved in water and can produce H plus ions. So we have a flowchart here of the way we name acids. So we have basically you have acids, and they can form binary acids. So that's hydrogen and a single nonmetal. These are acids in which hydrogen is bonded to a single nonmetal. So basically what you do is you write hydroic. Okay, so when hydrogen bonds to a single nonmetal, you write hydro blank ic acid, right? If there's no AQ state, so if it's not dissolved in water, you just would say hydrogen fluoride, or however you would name these compounds normally. Okay. Then you can have an oxyacid, so hydrogen bonded to an oxyanion. So for example, hydrogen bonded to the sulfate ion is called sulfuric acid. Note here that there's no hydro prefix. Hydro is the prefix that we use when it is a binary acid, but for oxyacids, there's no prefix. We just say sulfuric acid. Then we can also have other acids where we have hydrogen in some complex ion, and we just basically will take the ion name and add ic to the ending, right? So when hydrogen is bonded to the thiosulfate ion, we just say thiosulfuric acid. Okay, seems a bit complex, but you should be able to get a hang of it. There are also things called organic or carboxylic acids. These acids are molecules that have a carboxyl group of atoms in the molecule. You don't really need to know this part right here, the carboxyl group, but just this structure will help explain why we write the formula the way we do. So in these cases, we write the H at the end of COO instead of in front. So you'll see in the other acids, we always put H in front. As you can see here, we're putting H in front and H in front. But if it's an organic acid, we put the H at the end because we have, as you can see here, COOH. The H goes at the end. All right, so an example would be acetate ion with hydrogen would be acetic acid. All right, and you'll see in your complex ion charts, anything that ends with COO, you put the H at the end of the COO. Okay, so COOH. So naming oxyacids, just like naming oxyanions, the names and formula of oxyacids depends on the number of oxygens present. So we also have a way of naming these based on the number of oxygens present. So like for example, chlorate, recall, is ClO3 minus. However, if you have ClO4 minus, recall that that is called perchlorate. Or if we drop an oxygen from that, ClO2 and then minus, that's called chlorite. And if we have then if you have ClO negative, that's called the hypochlorite ion. These oxyanions, as we saw in the flowchart above, the oxyanions can bond with hydrogen and make what's called an oxyacid. And so we have specific naming rules for that. So if we have H bonded to ClO3, so HClO3, the name of that oxyacid is called chloric acid. If we increase the number of oxygens by 1, we would have HClO4, and just like we have the perchlorate ion here, the name of this oxyacid would be perchloric acid. Chlorite, where we have ClO3 and we've reduced the oxygens by 1, would be HClO2. And we would have, instead of chloric acid, we would have chlor, and right here, acid. So chlorous acid. Finally, the hypochlorite ion, when bonded with a hydrogen, becomes hypochlorous acid. Okay, so what I've done in red for you is exactly what you see here. It's just the rules for oxyacids. You basically take a look at the root. The root is ic acid. If you add an oxygen, it becomes per-ic acid. If you take one oxygen away, it becomes us acid. And if you take two oxygens away from the root, you get hypo-us acid. So H2CO3, we would call that carbonic acid. Okay, so that would be called carbonic acid. H2CO4, because it is one oxygen above H2CO3, we would call that percarbonic acid. H2CO2 would be carbonous acid. Okay, just literally following the rules right beside here. And then one oxygen away from that is hypocarbonous acid. All right. So in this table here, you have a whole bunch of boxes here, and it's just basically asking you to do the same thing, right? So sulfuric acid is your root. You add an oxygen to that, and that would be per sulfuric acid. You take an oxygen away, and that would be sulfurous acid. And if you had two oxygens away from the root, that would be hyposulfurous acid. Okay, so you can go and complete these tables based on the rules that you see listed above here.